Okay, good morning, students. So, today our topic is flip-flop and latches. Flip-flop and latches design. So, in our BTech syllabus, we already discussed about what is flip-flop and what is latches. Okay, we already read this topic in our BTech syllabus that flip-flops and latches are the memory elements. These are the sequential circuits. What is the mean of flip-flop? Flip-flop is nothing but a combination of various gates, and it works when clock pulse is applied into it, and according to the time interval of clock pulse it provides a certain output. Okay, there are the four type of flip-flop, such as SR flip-flop, JK flip-flop, T flip-flop, D flip-flop. Okay, we already read this topic in our BTech syllabus. Same as latches. These both are memory elements. The only difference between latches and flip-flop is that flip-flop only works when clock pulse is applied into it. So according to the timing of clock pulse, according to the time difference between two clock pulse, it provides the output. But in latches there is no limitation of clock pulse. It means that it is independent to the clock pulse. It operates when input is provided to the circuit, and according to the input and behavior of gate, it provides a certain output. Now the question generate, why we study this topic here? Because we are discussing here that there are the several ways through which we can minimize the power that consumed by this flip-flop and the latches. Okay, because we know that in any integrated circuit, in any complicated circuit, flip-flop and latches is always required, because these are the basic building blocks. Okay, but we are mainly focused how the integrated circuit works on less power, how it dissipates less power. So we need to focus on the design of these flip-flop and latches also. We have to focus that how can we design this flip-flop and latches so that it consume very less power. So if these elements consume less power, so we can say the overall power that required by the integrated circuit will also reduces. Okay, so I prepared this topic for Gary Yep book, also with the Rabbe book. So these are the content by using content from the Rabbe book, and this one is the content from the Gary Yep book. But I found that the content that is provided in Gary Yep book is very important as compared to Rabbe book. So I am starting this topic by using this Gary book. Okay, so flip-flop and latches are very important component. We already know that, and its significance is very high in digital VLSI, because in digital VLSI we always, when we need to implement any circuit, so always we require these flip-flop and latches. Okay, now the question arises that why we use this flip-flop and latches. Actually, the main purpose to use these flip-flops and latches is to control the timing interval. Along with it is also act as a memory element. Okay, so we can say in the synchronous circuit, these elements are connected in the starting and end point of any path. Okay, so when we connect these elements in the starting path and the starting point and the end point of any path, so it works according to the time interval what we required. It provides the timing interval what we required. Okay, so because this flip-flop works on the clock pulse, so that we can say this consume very large amount of power. Okay, because the flip-flops have input ports, in which some ports are responsible to collect the data, and some ports are responsible to collect the clock pulse. So when we provide the clock pulse to these integrated circuits, so these clock port, or we can say these clock pulses consume very high amount of power. and because of this flip-flop, the power requirement will increases in the integrated circuit. Okay, so if we compare the data path, if we compare the data input and the clock input, so because the data rate is very less as compared to the clock rate, because of the clock rate, yes, the data rate is very less compared to the clock rate. It means that when we provide the data input to the clock pulse, so it consume very less power, but when we provide the clock pulse to any flip-flop, so it consume very high amount of power. Okay, so according to some calculation, it is found that the power that is dissipated because of this clock pulse is 40% of the total power that is dissipated from any flip-flop. Okay, this that is dissipated from any device, not flip-flop. So this power dissipation, so this power dissipation is need to be minimized. Okay, so to minimize this, we know that the all power is divided into these factors, that is capacitance, voltage, voltage that is swing voltage, we can say, or we can say it is as supply voltage, and the last one is most important, that is frequency. Frequency means the clock frequency that is provided in the input port of any clock pulse. So it is very important factor. If frequency is high, so automatically we can say the power dissipation will increases. Okay, so if we want to design any flip-flop, so we need to focus on these parameters only. It means that if we want to minimize the power dissipation, so either we need to minimize the load capacitance, either we can minimize the supply voltage that is provided, or in last we have to reduce the frequency, we have to reduce the clock frequency. But if we reduce the clock frequency, so automatically the speed of operation will reduces. Okay, so by using these factor, we can only by focusing this factor, we can design any flip-flop, that produces that dissipated less power. Okay, so some circuits is mentioned here. This circuit is mentioned here. Okay, this circuit is nothing but some modification we have done to minimize the power dissipation in any flip-flop. So these are the some examples of latches. These three circuits are the example of dynamic latches. This one has the static latches. Why these are known as latches? Because there is no clock pulse ported in the input side, so it works when input is provided. It doesn't wait for the clock pulse. Okay, same as these circuits are the example of some modified flip-flops. Okay, these are the examples of some modified flip-flops. So in these circuits, all the circuits have some advantages and some disadvantages. Some advantages and some disadvantages. Some of the circuit works on less speed, and but the advantage is that it also consumes very less amount of power. So here, what is the advantage? Here advantage is that it consumes very less power, so definitely the power dissipation will be less. But what is the disadvantage? The disadvantage is that its speed is less. So if its speed is less, so definitely the device that is implemented by using this flip-flop also works on less speed. Okay, when we provide clock pulse, so there are the two phases of clock pulse. Okay, positive and negative phases. Okay, so the first circuit that I have represented here, this one is the dynamic latch. This circuit eliminate the need of dual phase clock pulse. Dual phase means positive phase and negative phase. It eliminates the need of dual phase clock pulse. This one is the latch, this one is the latch, this one is the latch, this one is the flip-flop. Okay, so this first circuit eliminate the need of dual phase clock pulse. So how it affects the circuit? Because we know that when we provide dual phase clock pulse in the circuit, so to generate this dual phase clock pulse we need a phase splitter circuit. So when we add some extra circuit with this flip-flop, so definitely the power consumption will increases. So if it works on single phase, with non-overlapping clock pulse, so definitely we can say the some power will reduces. Okay, one threshold voltage less problem occurs when one is propagated into it. Okay, so there are the various type of circuit. So if we implement any flip-flop by using NMOS instead of using transmission gate, these elements are transmission gate. So if we implement the circuit instead of transmission gate, if we implement it by using NMOS, so NMOS have all these advantages. So all these advantages means that if we implement the circuit by using NMOS, so the load capacitance is reduces in NMOS flip-flop. So if capacitance is reduces, so definitely the power will also reduces. But that's what is the disadvantage? The disadvantage is that we know that in NMOS circuitry, when the input voltage is high to a certain threshold voltage, so the NMOS works as a on circuit. NMOS works as a short circuit. Okay, so when input is 1, so at that time some threshold loss problem occur when we implement any flip-flop by using NMOS circuitry. Okay, so this first circuitry that is implemented with transmission gate, this transmission gate avoid the problem of threshold loss that is occur when we implement flip-flop with only NMOS. Okay, so every circuit has some merits and some demerits. The main factor depends the main factor is that what is the purpose where we need to use these elements. If speed is the main concern, so we use the different flip-flop. If if the power dissipation is the main concern, so we use different circuitry. So according to the requirement, we use different type of these different circuits. Okay, these are the latches, because no clock pulse is provided into it. When we provide input, so according to this input it provides the output. Some D flip-flop and modified D flip-flop structure is represented here. Now we implement flip. Now we these are the structure, these are the circuit diagram of flip-flop. Now what is the difference between flip-flop and latches? We already discussed that flip-flop only works when clock pulse is applied, and there is no need to provide the clock pulse in the latches circuit. Also, we can say when we cascade two latches, so we found the flip-flop. Okay, so these are the some structure of flip-flops that works on very less power, that consume very less power. these flip-flops is mainly used to increase these low power high speed flip-flops are mainly used when we want to increase the speed of any circuit, when we want to connect any flip-flop in any circuitry that works on high speed. So at that time we use these flip-flop in that place. You can see here where various elements are connected. You can see here various elements are connected. It means that the area is the area that is required to fabricate this element, to connect this element in the circuitry, becomes high. So if the area is high, so definitely if area is high, the number of component is high, so the area and power dissipation problem definitely occurs. But the advantage is that it works very fast. So in very in a very microprocessor, we use these elements in that place. One more differentially encoded flip-flop circuitry is mentioned there. Exotic differential signaling method. One more structure of differentially flip-flop circuit is mentioned here. Here you can see this one is the latches, this one is the internal circuitry. When we connect latches with some modified circuitry, so the speed of the this flip-flop becomes high, but because of the number of component, the area and the power dissipation will be high. So it works when we need to increase the speed of any circuit, when we need to increase the speed of any operation. So at that time we connect this differential flip-flop there. Here M1, M2, M3, M4 all are the these are the CMOS configuration. These M1, M2 are the MOSFETs that is connected here in the pair of cross-coupled feedback inverter. Here this M5 provide a current path to the ground. And it works when input is when we provide the rising age of input. Means that when we provide what as the input, so at that time the NMOS works. So sometime this M2 and M4 will moves to the floating region. So to bypass this stage, we connect this M5 here. It provides a direct path to the ground. So because of this M5, the float it eliminates the need of floating stage of M2 and this M4. Okay, now self-gating flip-flop. These are the example of self-gating flip-flop. Now what is the meaning of self-gating flip-flop? We know that when we provide input, so according to the input the flip-flop works. But the flip-flop also need a clock pulse. So when we provide clock pulse and data input, so when we provide these both inputs, so according to this input we get the output. So according to this input we get the output. Okay, so the part of clock power clock power that is provided to the flip-flop is also provided as an internal clock pulse, is also provided as an internal clock buffer to control the transmission gate. Here these are the transmission gate. Various transmission gates are connected here. So when we provide any clock pulse, so some part of the clock pulse power is also provided to the internal clock buffer that is connected in the transmission gate. So in self-gating circuit, when the input equal to output, so the switching power is suppressed. When the input equal to output, so the switching power is suppressed. So this technique is known as self-gating flip-flop technique. Okay, this one is somehow similar to the clock gating. Okay, so here the power is consumed, here the power is reduced, here the power is reduced. Because we eliminate the switching state, so definitely the power will reduces. Okay, so this one is the example of self-gating flip-flop. This one is the example of self-gating flip-flop. One comparison between self-gating and regular flip-flop on the basis of switching rate and power dissipation is represented here. Okay, so these all are the part of low power flip-flop, some circuit diagram of flip-flop and latches that works on low power. Okay, so in next lecture we will discuss some other topic. Okay, thank you so much.